So what we're going to do here is create a moving platform. This might be a little bit more complicated, but it'll be cool. So what I'm going to do is I'm just going to grab, let's say this one. I'm just going to duplicate it to use it as my example. So we'll start with this because it's already got some stuff on there. Okay. And let's make it a little bit smaller so it's what have you. And I'm going to rename it, moving platform, right? Okay. So this already has, so it's a 2D sprite object, right? And it's already got a box collider on it, and it's just a regular box collider, no trigger or anything like that. So that way we can jump on it and voila. Great. So what we're going to do is we're going to create a new script for this. So we're going to create C# script, and we'll just call it moving platform script. Okay. And let's open it up. And we are going to have to add some stuff. Okay. So let's add some variables to start with. All right. So we're going to need at least two things here. We're going to need a start position and an end position, right? So let's just go ahead and do a public public let's do private first. Sorry, private vector2 start position. Okay, so that will hold our start position, and we're going to do a public one for the other one. It's going to be another vector2, and this will be end. Oops, not a capital E. End position. Right. So we have a start position and an end position. And that should be pretty good. The other thing we're going to need is how long we want it to take, right? So when it's going from A and B, right, start and end position, should it take 5 seconds to get from there to there, or 2 seconds, or you know what I mean? So we need to have a variable that's going to hold how long that takes. So we'll just do another public. This time it's going to be a float, and we'll just say duration. And I'm going to set it initially equal to 3. But you could just put duration and change the number when you get into the inspector. It's the same thing. Okay, good. So that's fine. I'm going to get rid of this gobbledygook. So one thing that we can do right off the bat is set up what the start position is, right? So if you notice, I made it private. So what that means, the start position is going to be, I'm going to set it equal to the transform dot position. Boom, that easy. So this is going to be attached to this object here, right? So when you have a script, when you say transform, that's this, and then dot position, that's this, because it'll basically it's whatever it's attached to, that's what it's looking at. I'm going to have it basically have the start position be wherever the object initially is. That's the start position. So I don't have to punch in any numbers on that. We will have to punch in the end position. But that's not that big of a deal. And we might have to change this to a transform. But actually, let's save this first to start with. Go here. And make sure you got the moving platform selected. And I'm going to go ahead and throw the moving platform up here. Great. And I just want to see something. Let's say I grab platform. It won't let me do it. Okay. Let's leave it alone. Okay, that's what I was wondering. All right. So now we need to find an end position. So I'm going to switch this up just a little bit. So we're going to also on this, let's do it after this. We're going to do a public transform. It's going to be the type. And we're going to say end position object. Okay. And I'm going to go ahead and make this one private. And what we're going to do is we're going to say the end position will be equal to the end position object dot position. Okay. So what that means is basically it's going to get its start position from the object itself, whatever this is attached to, right, which is the moving platform. And then end position, we're going to get it from an object, the transform of an object that I'm going to drop onto it. Okay, so let's go ahead and save that. Go back here. And what I want to do is create an empty. And we're just going to call this end position. Okay, and I'm going to go ahead and I'm going to take this end position. It's just an empty group. And I'm just going to set it over here. Alright, so we have this, and then we have this end position. And I'm going to click on the moving platform, I'm going to click, and I'm going to drag this into its end position object. So basically, it's going to get its end position from this object. So it's going to move to wherever this object is. That way we don't have to punch in a number or anything. I could just set this to wherever, and then it's going to go back and forth between wherever this position is. It just makes it easier, because otherwise I'm trying to guess a number and be like, oh, I think it's 3. You know what I mean? This way it'll just be this object. It would just be easier. Okay. Okay, so we have our start, we have our end position, and that should work fine. All right. So now we need to do is have this actually move. So let's get rid of that. I don't need the gobbledygook. And what I'm going to do is, instead of putting an update, because we want it to move every frame, instead of putting it in there, what I'm going to do is I'm just going to make a separate function called move, and update will just call that function. Okay. So I'm just going to do void move. It's a pretty complicated name. Move. Boom, like that, and that will handle it. Okay. So we need to add a couple of variables. Basically, what we're going to do is a type of interpolation, and that just means that it's going to find. You're going to give it 2 positions, and then the computer, the processor, is going to determine the different steps in order to go from point A to point B. But it needs to be written like a kind of like a specific way. Okay. So we're going to have to add a couple more variables up here that are just going to be used for what we're doing. So I'm going to put these kind of in a separate section, and we're going to do private float start time, okay, because we have to have the time that which we're starting in order to add that duration and stuff too. We're going to have a private float t. This is going to be used to find the each increment of what we're doing, okay? And I think that should be good enough for now. And then we're going to add more. We're going to add more stuff in between. Okay. So let's go ahead and make sure we're calling move every frame. So I'm going to do move up here. I keep putting 0, and I mean to do this. Okay. So it's going to call move. So move's going to run every rendered frame. And then what we're going to do is I'm going to say t is equal, so t will equal time dot time, which is the current time, minus the start time, okay, and then divided by the duration. So basically what's going to do is it's going to whatever the current time is, and then the duration. So we actually have to set up also the start time up here. So on start, we have to go ahead, and I'll just do it for these two. We'll just say start time is going to be equal to, oops, we're going to give it the value of time dot time. Okay, like that. So basically we're going to say when time starts, which it'll be 0, we're going to set that up as start time. Okay, so that's all this is doing. It's just saying whatever time the thing starts moving, and then divided by the duration. So if you think about it, if it starts out at 0 over, let's say 3 seconds, because I think that's what I put up there, right? Yep, 3 seconds, this will equal 0. And then when this is 1, right, to 3, that'll be 1/3, so it'll be 0.33. And then when it's, 1.5 seconds, that'll be, 1/2, right? So it'll be 0.5. and then, you know, all the way to whatever. You can do your increments, but basically this is going to result in a number that goes from basically 0 to 1, and that's basically what we're doing. So over time, this will give us a different fraction or decimal point, you know, representation of a fraction that goes from 0 to 1. That's what we're kind of after. All right, and we're going to use that in order to find the position through time. So now what we're going to do is you're going to do transform dot position. So we're going to take our position and we're going to give it, we're going to move it. This is how we're moving it. So a new vector 2, and what it's going to be is mathf dot smooth step, and we're going to smooth step the start position dot x with the end position dot x, and then after that it's going to be t, and then we're going to go ahead and do the other one. It's going to be math f dot smooth step, and it's going to be the start position dot y, and start position end position dot y, end position dot y, and then t, and boom. Let's see, yeah, okay. So might not make a lot of sense to you, but basically what's going to happen is that every time this runs, this move, which is going to run every rendered frame, it's going to create a fraction. It's going to be a decimal point, but it's basically a fraction that takes whatever the current time is versus the total time, right? So like I said, it's going to go 0, then it's going to be like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 1. Once it reaches 1, that's the end number, okay? Now we're going to use that fraction in here. So you'll notice we say, okay, take whatever the position, I want to move our position. So this is the position of the object this is attached to, which is going to be attached to the platform moving object, right? So this, we're going to take this position, and the position is going to be this new vector 2. So it's a vector 2 because we have x and y. And if you look, this section here is my x, and this section here is my y, okay? And what we're going to find for x and y, it's the same on both of them, but we're going to use this math f smooth step. So what this does is instead of it being linear, meaning like it'll move when it starts, instead of moving like, let's say there's 12 steps, instead of moving like one full whatever, and then moving one full whatever, and then moving one full whatever, which would give it a very mechanical movement. It's going to go zoop, like back and forth, back and forth. What this is going to do instead is it's going to start off with smaller increments and then speed up over time. So basically it will ease in the movements, not just literal like back and forth, which would be very mechanical, unless that's what you want. If it is, then you know you wouldn't want to do it this way, but I think it looks better if it eases in and out of its motions. So this needs two positions, so two numbers to compare, right? So we want to compare our start position and our end position of the x, and then it's going to use that fraction we created up here. And we're doing the same thing for y. So basically, that's how we're going to move it. So let's go ahead and preview it. And let's see. And it might act a little funky. There it goes. Yay! So what you'll notice is a couple things. So notice how it slowly speeds up, right? It doesn't start off going super fast. It speeds up and then it slows down. That's the smooth step. Otherwise, it would just go one consistent speed all the way, and that'd be very linear. Now, there is an issue with this. Like, it moves, and that's great, but obviously a big part of what we need to have happen here is we need it to go back and forth, right? We need it to ping pong. And there actually is a function called ping pong, but it's not gonna, like a built-in math f function. I think it's a math f function, I'm not sure. But that's not gonna help us much in this case. Another thing I'm gonna do real quick here is I'm gonna go to the game controller, and I'm gonna make the allow time like 60 seconds because it keeps killing my dude, and that's gonna be a problem later on. Okay. So it's going from here to here, but I need it to go from there back to there once it gets to here, right? Makes sense. So we need to basically fix that. All right. So in order for that to work, we're going to have to add another variable, basically one for the direction it's currently moving. Okay, so we'll put it right in here, and we'll just do a private int. Int, and that's going to, we'll just call it plat direction, and I'm going to set it initially equal to 1. So we're going to do 1 and -1 for basically our platform direction that it's going in. Okay, that should be pretty straightforward. All right, and what we're going to do is in our update, what we're going to do is this. We're going to say if t is greater than or equal, that's not at all what I pushed, greater than or equal to 1, then you're going to go ahead and reset the start time, or the start time is going to become, you're going to restart the start time to time.time, and we're going to change the plat direction, so we'll do times equals -1. Like that. And a thing. Okay, so this might be kind of confusing. So basically what this is doing is this. If you remember that t is going to go through here, it's going to go from 0 to 1, right? Basically what we're saying is once it reaches 1, which in this case, the first time it's going to reach 1 is going to be when it gets to here, right? So if we had t as a public variable, you would see it start at 0, 0.1, 0.3, 0.4, 0.5, 0.6, and then it'll get to 1, and that's when it stops, okay? So what we're doing is we're just using that as a guide. And we're saying, okay, once it gets to 1, I want you to basically turn it around and do what have you. Okay, so we need to, in order for this to work, it's based on that start time. So the problem is that we need to reset the start time so that it can rerun this. So that's why we have to refresh the start time again. And I want to change the direction of the platform. I haven't used that in here, but you're going to see in a second. So inside of here, we're actually going to do this. We're going to set up if the plat direction is equal to 1, so meaning moving to the right. Okay, I'm just going to Control X, tab Control V, and that didn't work real well. Delete. Okay. So if it's moving that direction, do that. Else, so basically we're going to set it up for the different platform directions. And I'm just going to go ahead and, tab. Okay. Else it's going to do this. So this is fine. So right now we're saying if it's positive, go, go towards the end position. But if this number is negative, right? So basically this plat direction, it's going to take whatever it is and multiply it times -1. So if it's positive, that'll make a -1 number, right? When it runs the first time. But when it runs again and it's a negative number, if you take -1 times -1, it gives you +1. So basically it's going to turn this number from 1 to -1 to 1 to -1 back and forth, which will allow us to make it go back and forth. So when it's in a positive direction, it's going to go from the start position to the end position. But then if it's not positive, meaning it'll be negative, we want to go from the end position to the start position. Start, end, start. Okay. And let's save it. So basically, it'll go back the other direction. So every time that it reaches 1, that t gets to the end, it's going to restart the time, and it's going to change the direction. So we'll save that, go back here. It should go back and forth at this point. But we are going to have an issue that you'll see in a second. Not with the movement, but with something else that's kind of stinky. So, yay, it goes there, and then it goes back. So he'll go back and forth. And what's cool about this is this. You can actually change the position. So you see it's not working at all. Why is it not moving up? All right, let's try moving this. It should have been going up and down too. Let me see. Oh, you know why? Because it initially sets it up. It's not doing it like real time all the time. But you can see I can set that wherever you want. So if you want to make like an elevator, you can just point it up and it'll go up and down. Or if you want to go diagonal or what have you, it will do all those things. So it's pretty dynamic and pretty cool. But we do have an issue with it, and I'll show you right now. So let's say we go like this. I'm going to take this platform, move it back over here, and I will show you what the issue is. Come on. So watch this. I got the stupid bouncing thing, but that's not the issue. Okay, watch. No! You have to walk with it, right? So there's nothing telling the player to move with it. So it would be nice if it was sticky, so I could, you know, make it work a little bit better. So that's an issue. So we're going to fix that right now. So to fix that is going to be this. It's not super complicated, but it is going to be like just another thing that we need. Okay. So what we're going to do is add another variable, private game object. Wait, that's why. Object. And it's just going to be the player object. Okay. And so what we need to do is we need to have the player object stored. And what we're going to do is we're going to test whether we're hitting, the player's hitting it, right? So we're going to go ahead and just set up the player object in my start. We'll just go ahead and do game object.find. And we're just going to look for the player object. Okay. So now it will look for the player object and it will store it in here. Okay. And now we can test against it. So what we're going to do is this. We're going to go ahead and, so now we got move working. We're testing the thing. We're going to add 2 new functions. So you might be familiar with the void, don't type this, on trigger enter 2D, right? We always use this, and this works fine for a lot of things. Collider 2D, right? We always write this out, and we're like, great, it works. That's not really going to work as well for us on this case because we'd have to have a trigger on there, and we are going to run into a problem where it's going to be competing with other elements. So we're going to do something else that's actually a little bit easier, and it's going to work a little bit better for what we're doing. So instead of on trigger enter, which you're familiar with, oh, you know why we can't do it? This is the other reason. If I take this, and if I make this instead a trigger, well, now when the player goes to jump on it, he's just going to fall straight through. So I can't use on trigger enter. And I can't put another box collider on there because then they compete with each other. It doesn't usually work well. So we're going to use a different thing altogether. Keep doing that. Okay. So it's not going to be this. It's going to be void on collision enter 2D. And it's going to look for a collision 2D. I'll just call it COL. Like that. On collision enter 2D. I spelled that right? I think so. So it's going to say when something hits it, not being triggered, then what we're going to do is we are going to test what hits it, right? Because I don't want it to be anything, because otherwise it'd be hitting other things and it won't work. We're going to say if the thing that we hit, if the game object of the collision, if its tag is player, then do something, okay? We're going to want to do something, and we're going to do another one of these. Actually, no, we'll leave it because we'll just copy and paste this. What we're going to want it to do is this. We're going to take the player object, right? Because remember, we already stored that up here. We're going to say we're going to take that player object, and we're going to take its transform.parent equals transform. Oops, like that. So basically what that means is that we're taking the player object's transform, its position, and we're parenting it to the transform of this object. And in this case, this object is the moving platform. So basically we're going to parent our player to it. That's how it's going to work. But that obviously ain't going to be great forever, because as soon as we try to jump off of it, we're still going to be moving with it, which is kind of funny, but you probably don't want that. So we need to also do, we'll just copy and paste it. We're going to copy this, Control C, Control V. Oops. So just like the triggers, we also have exit, and we'll say player, and then what we're going to do is we're going to take the player's parenting, and we want to parent it to null, to nothing. So unparent it from whatever it's parented to. And we'll save that. So basically what this is going to do is that when our player hits it, has a collision with it, it's going to parent to the thing that it hits, in this case the moving platform. And when it unhits, it will unparent it. So now, when we go into here, and I play it, come on, you can do it. Now I gotta wait. Come back. Now you can see, and what's actually happening is this. Well, it's not really showing it, but it's now parented. Its position is now parented to this. But I can still get off, and now I'm no longer parented to it. Okay, so yeah, that's the moving platform. It's a little bit of a pain, as you probably have noticed, but you know, it does work. So yeah, good luck with that.